recording now, and then I'll paste these things. So can you give like a 1 minute brief intro about like who you are? You don't have to say your name or anything, but kind of like what size company you're working at, what are you looking for, stuff like that.
Yeah, sure. Yeah, hi. I have like around 4 years of experience, and I'm working at a L4 position at a startup. Currently targeting FAANG companies.
Okay.
Yeah,
And do you have any interviews like lined up, or are you going to be probably applying like after the start of the new year? Because I know it's kind of dead right now with the holidays.
yeah. Like I'm currently not applying. I'm just getting started with the MOOCs and things. Maybe I'll apply after December because these are holiday seasons, so we don't get enough calls and all. So
Yeah, yeah, makes sense. Okay. All right. So let me paste the question, the first one, and let me know if you have any questions.
okay,
And I don't think so. We're gonna do it where you don't need to run your code. So you're just gonna like write some code, and then we can talk through the approach. Like just do a dry run on an example problem. But yeah, let me know
okay,
if you have questions about this one.
okay. You have a binary nodes number from 0 to n-1, where node I has two children, left child and right child. Run true if only if all the given nodes form exactly one valid binary tree. Okay, a node I has two children. Run true if all the given nodes form exactly one valid binary tree. If node I has no left child, then left child I will be equal to -1. Similarly for the right child, note that the nodes have no values. Okay, and
Let me give
that
you
we all.
some inputs and outputs as well. So here's a couple
Okay,
examples.
okay. So, okay, maybe I'll take the example one to understand the problem. So, okay, n equal to 4. So, we have four nodes, number from 0 to 3, and return true if and only if all the given nodes form exactly one valid binary tree. So, maybe left child and right child. So, I think the root node would be 0 here in this case,
Okay.
and left is say 1, right is 2. Then this is -1.
So -1 just means like null.
Okay. Yeah. Uh, okay. And then right child is again null. Then we come to 2, which again has like uh, this is 3, and then this is -1. Then maybe it would come here, something like this, which is -1 and -1.
Yeah.
Is this correct?
Yeah, so you can get rid of the -1s because they're just null, and then it's easier
Yeah,
to see
yeah,
the
these are
tree.
nulls.
But
Yeah.
yeah, that is correct. Yeah. So you could see how that this would be like a valid tree, basically.
Okay. Something like this.
Hmm.
Okay.
Yeah, so I think the left child of 2 is 3, and the right child is null. So it would be this way.
Oh,
But
this left.
yeah, same thing. Whatever here.
Okay. So now we would have to check that we would have to return true if all the given nodes form exactly one valid binary tree.
Hmm. So yeah, the
Okay.
criteria is they need to make a valid tree, and it needs to be only one.
Okay. Okay, so in this case, this node itself can be one valid binary tree. Same with this can be one valid binary tree, this can be one valid binary tree, and then this can. Okay. Return true if all the given nodes form exactly one valid binary. Okay. The condition for valid binary tree would be that uh, that like what was the condition for being a valid binary tree?
Yeah. So what is your definition of a binary tree? I guess.
Uh, so like uh, so basically valid binary should be where each node should have both left and right child.
Does it have to have both left and right?
No, not necessarily, but uh, like there should be no cycles for
Hmm.
being a valid binary tree.
Yep. So that's correct. Can't have a cycle, and it can have up to two children. And
Okay.
I guess there's one other part. So you mentioned no cycles. Every node can have up to two children. And what's the? There's one more criteria. Can you think of that one?
Uh, like it cannot be null, I think.
I mean, null is a
Yeah.
valid binary tree, but like, there's it also can't be like this, right? I can't have like 0 to 1 and then like 2 to 3. Like the whole thing has to be connected. So that's the third one.
Oh, okay, okay. Yeah, yeah. So basically only one connected component kind of something like that.
Hmm.
Okay. I'm just noting it again. Two children, no cycles, and then maybe I should not be disconnected components.
Hmm.
Okay. Same way, I'll just maybe just add it for this one. Super fast. So this is 0. This will be 1, and then we will have minus 1. This will be 2. Then we have minus 1, which is null, and then I will have 3. Then after 3 we again have 3, just kind of left of this, and then we have minus 1, which is null. Then we have null. So this is like this: 0 1 2 3 3, and we are saying this is not a valid binary tree. Okay.
Yeah, because like you basically have 4 nodes, right? 0 to 3, and here 3 is a left child of 2, and it's also a left
Right.
child of or it's also a right child of 1. So this is not valid for yeah, because this would basically be a cycle.
Okay. Mm, mm, okay. Yeah, yeah, right. Both. Okay, understood. So when I suppose start visiting the tree, then I first visit the root node. Then I can either visit the left child or right child. So when I visit left child or right child, then both could visit tree. And suppose if first visits this node first, then like this, like out of one or two, both could visit this three.
Hmm.
So basically, like how we could detect cycle is that uh, if we see a node is already visited in the path before this path completes, say before the uh, node 1 marks this node 3 visited, like
Hmm.
in this path 0 1 3 3, and even 0 2 3 3 could mark this as visited. So if like for other path we see the node is already visited, then we know there is a cycle.
Hmm.
So maybe we could use like basically we could just check if there is a cycle or not, and if there is a cycle, then uh, we could say that it is not a valid binary tree,
Hmm.
right?
Even if there's
And
not a cycle, like for a tree, like a node can't have two parents, right? So I guess
right,
maybe you can write that, but like For example, I can't have like 0, 3,
Zero.
3, right? Because that
Right.
would, like, this is not a cycle, but it's not valid either. So that would be another one. Because this is the
Okay.
same node, right? Like every number is the node, so like then 3 has two parents basically, so this wouldn't be valid. Something like, does that
Okay.
make sense?
Yeah, makes sense.
Okay.
Okay. Uh,
But yeah, I think what you were saying does make sense. So you'd basically like go from like 0 to 3, and then you'd see it's there again, and then yeah. Okay.
Also, the tree is undirected, right?
A tree is, so what do you think? Is a tree undirected or directed? Like
So,
if I
so
have a,
at least tree is undirected only. Yeah. Basically,
so I have an array of left children and right children, right? Um so that means I can go from a node to a child. Can I go back up?
no, no, no.
Right.
Okay. So, 1 second, just let me think. This, okay, trees. There is one more property that we have that. Okay, wait, no, that would not apply here, but 1 second. Okay, so we just need to create cycles around it. So, we have the root node, and then we have this left child and right child. So, and the number of nodes we will have is n minus 1.
Hmm.
Okay, so
The number of nodes we have is n. They're just numbered from 0
yeah,
to n minus 1.
0 to n minus 1, right? Okay, so maybe I'll just take this example. Uh, what I would do is I'm just thinking of try running this with some
Hmm.
approach, and then if that approach looks to me, then I will go down to the implementation part.
Sure.
So suppose we have we basically always will have root node has 0, and if say the length of the node that is given to us is 1, so then it is a valid binary tree. So that could be like our base case, right?
So if the
And
length of the tree we're given is 1, yeah, okay, yeah, makes sense. So if
yeah,
like n equals 1, it's always valid.
yeah.
Is that always true no matter what the left and the right child are?
Uh, if left, suppose if left is both -1 then it is valid.
Hmm.
If both are 3 3, then it would not be valid, like as you called out before, because both are same node. So
Yeah. Or if I
this,
have like n equals 1, and then it's like 0, 0, this is also not valid, right? Basically saying the left child of 0 is 0 and the right child of 0 is 0, or even like this wouldn't be valid either, because basically we have one
yeah,
node, its child is itself, so that's a cycle.
right, right. Yeah, this also will not be valid. This is example 2, this is example 1. So yeah, maybe we can have some base case like this for n equal to 1. I'm just thinking for now we could have some base case like this, and then uh, I basically check left and right. I can kind of maintain a queue where uh, I can kind of maintain a queue for nodes that I'm visiting. So
Hmm.
say I visit 0 left. Also, I could have a set here where I could just insert the node values that I am visiting.
Hmm.
So first I visited node 0, right? And then now I am going to left side, right? So this is my queue where I am inserting that I am on the left. I have inserted one, and then uh, I insert one here as well. So then after one, I would I'm basically doing a DFS traversal. So I basically check for left and right of one, which is null. So I return back to here again, right? And then I go to the right of this particular binary tree. So I try to visit 0 of right of 0, which is 2. I check in my set if there is a value 2 visited already. It is not, so I insert into set, and then I uh,
So I'm
okay.
confused. Why do you have a
Yeah.
DFS and a queue?
So yeah, sorry, my bad. So we don't need to maintain for DFS. So I just give go to 2, and then once 2 is visited, I go again DFS for the left part and the right part. So again I have 3. So the DFS is completed. Also, I would need to keep track of the nodes were visited earlier or not. So maybe I could have a visited tracker which is initially false, and it could be like the size of the array. So we have n node, so all would be initialized with false values like this. And if uh, it is already visited before the DFS is completed and the node is already visited, I would note that there is a cycle, and in that case I could return false,
Hmm.
and otherwise I would return true. Also, one more doubt I was having, maybe suppose if we had something like 0, 1, 2, and we had here say 3, and then here we had again 2.
Hmm.
So in this case, the values 2 and 2 are repeating, but uh, from the right side, I could just visit this. Like, there's no way that the nodes under 2 would be visited by someone else before me visiting like this.
Hmm.
So in this case, I feel this is a valid binary tree, even though the
So this would
values.
not be valid because technically there would be a path from 3 back to 2, right? Which would make a cycle. So like 2
So,
wouldn't be under it, 3 would point back to 2. So you'd go from 2 to 3 back to 2. Um, so that would be a cycle. So basically, like whenever you have a left and a right child, think of that as like a directed edge. So you'd have an edge from 2 to 3, and then from 3 to 2, and then that's a cycle. Does that make sense why that doesn't work?
1 second. I'm just thinking how it is forming a cycle.
Yeah, so I can show you in the drawing, might make it
Okay.
easier. So I have
Okay.
0, 0. Second. So you have node 0, right? Goes
Yeah.
to 1, which is fine. Goes to 2, which is fine. Um, Goes to 3, and now 3 points back up here. So that's a cycle. Like three's right child, its point is 2.
How 3's right child is pointing to 2?
Well, this is the tree you drew, right? You're saying if three's right child is 2, like in the thing you drew. So you said
So
three's right child is 2.
right child would be something like this, right?
Even if you write it like that, so think about it, right? Every node is unique. So can you have a node that's a parent and a child? Or can you have a node in a tree
Okay.
that like appears in 2 places? No, right? It
Okay.
appears in one. So
Got.
so whatever way you think about it, it's still not a valid tree. Like it has to
Okay.
appear
So
in one spot, and if it appears in multiple spots, it's an invalid tree.
what if we had something like this, that we had 3 or 4, and then we had like 2 here.
That would still be invalid because the 2 appears in multiple spots. Like think about just
Okay.
like in a binary tree, can a node appear in multiple spots? No, it can't.
Okay.
So it can't be like on one level and then on a further down level. That's not valid.
Right.
So I just
Okay.
said that like the left and the right are weighted edges. If you want to think about it in terms of left and right, that's fine. But a node can't appear in multiple spots.
Okay. Got it. Okay, so yeah, so then I think set would do the job. We could
Yeah.
basically, before inserting, before, like when we are visiting some node, we would just check in the set of that value is already there or not. If it is already there, then we could directly return false without checking anything else. So that would work. And for the DFS, I could just keep a track of visited array, and if it's already visited, then I could say that there is a cycle, and in that case as well,
Yeah,
I could return false. And then I would basically note, I think require this case also. This would already check with set, and in this case also, this would be completed with set. So we don't
yeah.
need to even have a base case.
Yeah, there's one other thing. I'll just mention it to you so you don't
Yeah.
take too long. So you said the root is zero. The root doesn't necessarily have to be zero.
Okay.
Like it is zero in these cases, but it's not guaranteed.
Okay. Okay, so then that case we could have something like if also, and would like, would n be always greater than or equal to 1, or it could be 0 as well, because in that case we could just check.
We'll just say n is always greater than or equal to one.
Okay, so we will say n is always greater than equal to 1.
Mhm.
Okay. Cool. So yeah, I think, yeah, this can be the approach that we can take. And
Okay.
I just wanted to confirm on like what is the parent signature that is given to us.
Sure.
Like, do we
So
have a root?
we're given two arrays, and we can just be given two arrays, and you can determine n from the arrays. But yeah, like I mentioned, because the root isn't guaranteed to be zero, how would you find the root?
Like root is not given to us something like this. Like,
No, it's
I was
not.
thinking.
So we're just given these two arrays. So we're just given a left
Okay.
child vector and a right child vector. So you could see like you're
Okay.
given uh, nodes basically, or you're given two arrays. But
Okay.
I don't tell you what the root is.
Okay. So, like, you suppose. r- Okay. So yeah. So in that case, since you told me that n is always greater than or equal to 1, that means left and right would always have some, at least one node present in them,
Yeah.
right? And only if, suppose if this is 0 and this was -1, or if both were -1, then it would come into the set, and I would say that this, wait, if both left and right were -1, then the root could have some valid value still, and uh, root could still have some valid value, like both left and right being null. So that could be a valid case. Otherwise, if it was 0 and -1, in that case also, if root value was different, it could be a valid case. So only when, I think, maybe we could have a check that if n is 1 and uh, both left and right are having different values, we could maybe return true in that case.
So here,
And
for example, you
yeah,
like this is invalid, right? Um,
right,
so how would we know like for just a generic array? How would we know like what can the root be? Is there a valid root? Is there not? Yeah, like because it's not only one. Like what if it's like this big thing
right,
and I move some numbers around? Then the root doesn't necessarily have to be zero, right? Like so, how
right,
would we
right.
know that?
How would we know what is the value of the root?
Yeah, because I can change these numbers around to where the root isn't zero. The root might be like three.
Mm, uh, I'm not sure like how will, if
So for
root is
example, let's say we have two numbers, right?
right.
So let's just make the root. Well, the root can be anything, but I'll give you an example. So just say this is -1, this is 0, um,
Okay.
like this. So here the root is 1, and so the right child of 1 is 0, and the tree is just 0 1. Or sorry, it's 1 0, right? So you see like line 9, the root here would be 1. And you can have other examples where I can just point this out to you. You might have multiple roots, and things like that. So how do I determine like what can be a root, what's valid, things like that?
Okay. Uh,
But do you see how like line 9, 1 would be the root?
One, because we don't have any other value. That is why we are saying it would be 1 because 0 is already there.
Yeah, like you basically have to say like what node can I make a root where I actually get a valid tree? In this case, if you make
Okay.
0 the root, it wouldn't be valid. If you make 1 the root, it would be valid. So is there a way for me to check quickly, like given these two arrays, what are possible valid root like values essentially? Like what can be a root and then do your strategy from there? Like now that I know what the root is, then I can do my like DFS and figure out like do I have the duplicates and stuff?
Okay. So you are basically saying if we are given these values, then could I figure out what could be the possible value of the root?
Yeah, because in
Uh,
the prompt, I didn't like it doesn't say
yeah.
you get a root. You just get the left and the
Right.
right
Right.
children. So
Right. So if I basically see it like this, so you are saying this can also be a valid case where we have minus 1, and we have minus 1, 0. So this would say, suppose if I assume root is something x,
mhm.
in this case, left is null, right is also null, and then on null we are okay. So you so in this case, what is the root value? 1 you are saying,
It
right?
would be 1, yeah.
Yes, so 3 would
So 1
be
with the
so.
right child of 0. That would be a valid tree. That would satisfy this.
Okay. So basically you skip this, and then here's your minus 1 and 0.
Mhm.
Uh, okay. And what if this was 2 here? Then in that case,
So you can
uh,
assume all the numbers will be in range of 0 to like 0 to n minus 1. So in this case, because we have two, like the length is 2, it can only be 0 to 1. So we can never have a 2. If this was longer, you
okay,
could have a 2, but yeah. But we could have
okay.
something
So
like
basically,
this where there is no root and now this is invalid again.
okay, got it. Okay, so if this was then minus 1, in that case also, then this would be a valid answer because then our root value would be 0,
Uh,
right?
in this case, this would be invalid because I have two nodes, right? 0 and 1. I need them to be
Right,
connected in order for it to be a tree. Um,
right,
there are no connections at all, so this is not valid. Does that make sense? Like in order for it to be this,
right.
like this for example, um, I need the right child of 0 to be 1, so I'd need it to be like this. This would be valid. But because they're all
No,
negative
but
1, I basically have 0 and 1, and they're not connected at all, and so it should be false.
even single node can be a valid binary tree, right?
Single node can be a valid binary tree, but not if I have two nodes. That's what I was saying.
Okay,
Like this is not like I can't have like 0 by itself and then 1 by itself. I need them. I need every node to be connected.
okay, understood.
So n, I mean, you can take n as an input, but basically n is the length of the array. So in this
Right,
case, I have two nodes, no connection, so this can't be a valid tree.
okay, okay. So like the base case would be then we kind of check the arrays, right? If like they have the values, then it is good. Otherwise, if all the values are minus 1, then that case we would say it's not a valid binary.
Right, but we can also have a bunch of other stuff. Like we can have this. This would also not be valid.
Zero,
There's like a bunch of invalid cases.
huh.
So
This
you have
this
to.
would be covered by our set where we say there is some value 0 again we are inserting kind of 0 again, so
Yeah.
0, yeah.
So you have to make sure that like, yeah, basically the root is valid and the tree is valid, and then yeah. Okay, so what's our strategy for getting the root then?
Yeah, so what I would do for root is that I would I would just start from left and right. I would
Mm-hmm.
not consider, like, I would not bother about the root here,
Mm-hmm.
and like I'll just start from this left of. I'll just start from the left. Start traversing from the left child, and if this is -1, then I go to this. This is again -1. Go
Mm-hmm.
to this -1 again. This is -1 again.
Mm-hmm.
Uh, since there is no value which is greater than 0 when I did the traversal, so like I for -1 I would not even do the traversal, but basically if I don't get any value which is like a positive number, once I added left child and right child, then I can say that this is not a valid tree.
But what if there's a bunch of positive values, right? Like if these are two
Yeah,
long arrays,
0.
they'll have a
Yeah,
bunch of positive. So how do I know which one of those is the root? Like this could be like whatever, 2, 3, 4, some other stuff like 0, 1, 2. I don't know, whatever. Like, so how do I know like which one of these uh like is the root? Like I don't like which index is the root because like there's a bunch of positive values now. So which one would you traverse from? And also keep in mind that like because these edges are directed, right? Like I can only go to the left and right child. I never go back up. So if I start
right.
from like line number 19, if I start from 2 instead of from 0, then I'm not going to traverse the entire tree. So I need to traverse from the actual root of the tree in order to like see if I traverse through it.
Okay. So in this case 3, 4, 5. So in this 5.
Mm-hmm. So
So
like
we
so how
have
would you determine like what's the root here?
hmm, uh, okay, the root you are saying would become from the trees itself, like from the left child and right child that is given to us.
No, I'm saying I guess to give you a hint, like so what can't a root be? Like what's the definition of a root?
Like root can't be null, and
Uh-huh.
root cannot also be a number which is greater than out of the range of 0 to n -1.
Uh-huh. Yeah, so it has to be in this range. So it has to be like 0 to 4. But what also like in a tree, what can't a root be? Like why can't this be a root? Like imagine
Hmm.
our tree is this, and why can't this
Yes.
be the root of the tree if we have directed
Why,
edges?
why can't 2 be the root of the tree?
Yeah. So basically a root can't have a parent, right?
Root.
Because in order for it to be
Yeah.
a root, it can't have a parent. So if a root can't have a
Okay.
parent, can we quickly figure out like what can be a root and what can't be by going through these?
Okay. So, like, if I see -1, I go again here -1, then we have 2, 3, 4, and 0, 1, -1. So suppose I say 2 is here,
Mm-hmm.
and then like we have 0 here, then I have 3 here to the left of 2, and we have 1 again to the right of 1, and then I have 4 to the left of 0. So,
So basically, to give you like another hint, I guess. So
yeah,
if a number appears in any one of these arrays, like let's say 2, let's say it's this. Um, if 3 appears in any one of these arrays, can it be a root?
if 3 appears in any of the array, can it be a root?
Yeah.
I'm not sure.
So these
Uh,
arrays are children arrays, right? So it's saying if 3
right,
appears here, that means 3 is a child. But a root
right.
can't be a child. So if 3 appears, can it be a root?
If 3 appears as a child, then it can be a root? No.
Right. So we can just like go through the arrays and figure out like what are the numbers that don't appear, and those are like valid roots. Does that make sense? So like if we have 5, for example, we we can just say like, okay, so our nodes are like 0, 1, 2, 3,
One,
4.
two, three,
So let's
and
just
whatever
check which
is
ones don't appear, and that can be a root.
okay.
And if we get
Yeah,
so then what should we do you think? If we get like we have like so let's say we have like valid roots or something, right? So let's
right.
say we get two roots, like 0, 1, and let's say we get 0 roots. What should happen for either of these cases?
Yeah, so if we get 0, comma 1, then we should be taking the least number, I think, which is 0, right?
So if two node like can a valid binary tree have multiple roots?
No.
Can a valid binary tree have no
Okay,
roots?
so you are saying even in that case, then the example would not be a correct example.
Yeah. So we can just check for like what are all the valid roots and make sure there's only one. And then from there do your traversal. Yeah. Like that you mentioned before. Basically just traverse from the root to everything else and see did we have a cycle and stuff like that.
Okay. Yeah. So yeah, then we could basically traverse and kind of maintain some mapping where we could check if something from left child or right child either leave something for the root, some value for the root, which should be a single value and should be within this range. Otherwise, we would say since the root is not valid, the binary tree would not be valid.
Yeah. Okay, so let's
Oh,
just move on from this problem actually, just because it's like taking a while. Let's go to the
yeah,
second one,
yeah,
just because I want to give you some time. So
sure,
okay,
sure.
so this is going to be the second one. Okay, and I can give you the function signature as well to make it simpler for you. So I'll just copy that in as well. There you go.
Okay, so we are given an integer array nums and an integer k. We need to return the maximum length of a sub array that sums to k if there is not one. We return if there is not one, return zero instead. What does this mean? If there is not one, return zero instead.
Let me give you
Okay,
some
basically if there
examples.
is no subarray.
That's
Okay,
right. Yeah. So if I had so a third example could be like nums equals 0, 1, 2.
okay, this will be like the default answer that we would be returning. Okay,
Yeah, and if k is like 10, then I would return 0 here. This would be example 3. Okay, there you
okay, got it. So I just added for the first example. So we have this, and we need to return the maximum length of a sub array. Okay, so we need to return maximum length as the output in the question, right? That sums to k. So suppose if I take this, minus 1 plus 5 is okay, 1 0 plus 5 minus 2 is 3. So in this case, the this subarray we could take, which is like 4, right? And this would give me like 1, but we since we need to return the maximum length,
go.
this would be our answer.
Yep.
And same way it would be for other case, k equal to 10. Since we were not able to achieve a sum of k equal to 10, we return 0 as the default answer.
Mm-hmm.
And in this one, minus 1 comma 2. Okay, so like for this, uh, what we could do is that we could apply kind of, I think, sliding window approach here, where I could what I could do is, if like I could start my sliding from the very first element, and I would say expand it to the right, becomes sum becomes 0. Like I could do it until it doesn't become equal to the value of k, and but I would also have to kind of think of a strategy to shrink it as well
Mm-hmm.
if it exceeds. So I'm just maybe going with sliding window for now, and I'll try to dry run my approach. If
Sure.
it looks good, then we can go with it. So we have like condoms here, and then say we have a sliding window where I add a sum of 1,
Mm-hmm.
and then I basically see sum is less than 3, so I could add minus 1, again becomes 0, I add 5, and then I add minus 2,
Mm-hmm.
which now makes k equal to 3. So like at this part of the array, I am equal to the sum, so I could store the length as, like in some variable I could store this length as 4, right?
Mm-hmm.
And I could also have a max length variable which would just track the maximum length we got so far while traversing the entire array.
Mm-hmm.
So since I got the sum equal to 3, I know that now I should kind of shrink my array, because now if I add anything to it or remove anything from it, that would not help me as part of the answer. But if we had 0 here, then in that case this would again become a maximum length of the subarray again. Or if I had 3, then I should kind of try to shrink it. So I'm just thinking, if what if I increase the length of the subarray, it becomes, the length becomes 5, and then if we have 3 again, so now while the sum is greater, okay, so maybe the condition we could have is, uh okay, while the sum is, while my sum is greater, like the current sum that we have, the sliding window sum that we have, while that is greater than k, till that point of time we could like kind of shrink the window that we have,
Mm-hmm.
right? We would keep shrinking from the left. And uh, if suppose, I'm just thinking, if what we had just negative numbers,
Mm-hmm.
so maybe we had like this. So in this case, I would have minus 5, minus 11, minus 15. So I will do minus 15 plus 3, which would still not give me the answer, but I could maybe have something like this, where this could be the maximum length, which is 2. So since, okay, can k be negative, or it would be always a positive number?
K can be negative.
Negative as well. Okay. So so my condition was sum is greater than k, we shrink the window. Okay. So in this case, suppose till here we have like a sum of minus 15. So my current sliding window is here. I have sum of minus 15, and then I have 304. So if I do this minus 15 plus 3, I reach minus 12. Minus 12 plus 4, I reach minus 7. So I'll not get a valid value. And since my sum is 3, what, like next time when I get 3, if I just get a value which is equal to k, I know it is valid, and I could just get rid of the entire sliding window. But what if there was something like 15, and then there was 3 and 04? So this would anyway get fulfilled in our normal flow. But what if we had something like this? I am at a sum of minus 15, and next I am seeing a value 3, or maybe I am seeing a value 4 and then a minus 1. So
Mm-hmm.
this could become a possible value. So I do minus 15 plus, oh sorry, okay, wait. Let me just think like this.
Mm-hmm.
I am minus 15, I am, next element is 3. So if now my sum is less than k here, my sum is less than k. So in that case also I need to go towards right. My sum is greater than k. So I should, my sum is less than k, so I should, it could be, if my, this was 10 and this is minus 20. So I will not be sure if this is because of me. doing here? Okay. We need to return the maximum length of a sub array. Like naive approach would be that we could iterate the array twice, like a open square approach, where
Hmm.
for each element we would start traversing, and once we get a sum of three, we just store the length and we keep updating on each iteration as
Hmm.
in to update the maximum length. That would be the naive approach, which is a open square. But
Hmm.
if n is very large, then in that case we would like uh, get a TLE there.
Hmm.
So thinking how we could optimize that approach. So I think since it is around some array, we could use a sliding window. But just I'm thinking that if
So I can give
I
you a
get
hint. A
about
sliding window. The problem you were saying is like you're like if it's too big, shrink, or if it's too small. But because there's negative numbers, no matter what it
right,
is, you can kind of just like add numbers in the end to make it work, right? So if I have this thing,
right,
there's always some numbers I can add to the end to make the whole thing equal to 3. This might be whatever it needs to be, like 12, whatever. So you can't really do a sliding window because it's not only positive numbers. Like if it's greater, it might be less than later on, and you don't
right,
necessarily know that you can get rid of what you have. So is there any other algorithm we can use, or like data structure,
yeah, okay,
to keep track
mm,
of sums essentially?
yeah, yeah, okay. So yeah, maybe 1 second. We need a sub array. Uh, we could so what if 1 second. So we need to we have negative numbers also, and if suppose if this was -3, it, if I'm thinking if what if I sort the array, but that would not give me the correct answer because
Yeah,
anyway I made sub
it
array.
has to be
Yeah.
contiguous chunk. Yeah,
Yes,
it
it
won't.
has to be a continuous sum, right?
Mhm.
So what else I can think of? Wait, if I do kind of zero, no, wait, maximum length of the subarray that sums to k. If I use, okay, I cannot use Kadane's algorithm because some
No.
can be negative here,
Mhm.
so that would also not work out. Okay, two pointer also would not work out because we would
Mhm.
have to sort and then we also kind of need to return a subarray. So wait, so I kind of know that I need to get a sum equal to this.
Yeah, can you use prefix sums somehow?
I was thinking of prefix sum, but how would that help here?
Mhm.
Maybe let me just try to.
Yeah, sliding window definitely doesn't work. Prefix sum definitely
Yeah.
does. So think about how it could.
So, like the sum would be 1, then it would become 0, 5,
Mhm.
3, and then become 6.
Mhm.
So, uh, this is a prefix sum. So when I have k equal to 3,
Mhm.
and I need to find, okay, when I have k equal to 3, so if I get a 0, that means I would, okay, if k equal to 3 here, so this could be length 4.
Mhm.
And also, yeah, if I iterate the array, I get k equal to 3 here. So I know that whatever this was, it would have basically would have become 0 kind of.
Mhm.
And so this I could written this as a length of 4. Uh,
Yeah, but what if you don't have, like, so in this
yeah,
case the longest thing starts from the start, but what if it doesn't start from the start? Like what if it's some other example where if it's like the middle two elements, like it's I don't know, like 8 -8 or some or whatever, like 9 -8. or let's see, 9, -4 maybe or something, and I want like 5.
Yeah.
Like
So
how would
yeah,
that work?
9 minus 4, 5. Okay, it gives 5. Yeah.
Oh, give
Basically,
okay,
just
okay. Well, whatever. If I have
maybe basically we have something.
-4 or something, is that good? Yeah, I just want to make sure like from the start it
Yeah.
doesn't give it to you.
Okay,
Okay, okay.
so
Let's do this. Let's do 1, -2. So this is
okay,
-1 plus,
-1,
yeah,
8
something like that. Does that work? There is
minus
no
5,
more 4.
3,
So
6, and
there you
k
go.
equal to 2.
Okay. So how would you do it in this case?
Yeah. So how we would do in this case? So we would need to say that if my prefix sum should be able to achieve a sum of 4 or not.
Hmm.
So if we have -1 and this here, okay, wait, okay, like in this case, this should have been our answer 9 minus 5,
That's right.
uh, which is like something around here.
Hmm.
So just thinking if this becomes 0, this becomes this sum 8 basically means that sum of first three numbers is this. So maybe like if I subtract a sum of subarray from other subarray,
Hmm.
then I think that might be able to help us, but I am just dry running on that approach. So if I say uh, this sum is how much, 8, and then I I got a 3 here. So 8 minus 3 is 5, which doesn't work for me. But if we had a something like if I do this is how much? Okay, one. If I have to, this is a sub array, and this is another. This is kind of 8 till here, but I just need the subarray sum of 9. So I do this minus this gives me 8, and I do 3 minus this gives me -5, which gives me 4. But
So that'd be
how do
3.
I?
8 minus 5 is 3, right?
No, I did 3 minus the sum of this entire subarray.
Oh, I see. Well, you
So
can't do like the whole point of
yeah,
prefix
I'm
sum
just
is to have.
thinking.
Okay, got it. Yeah.
Yeah, I'm just thinking like if I somehow could do something like this,
Hmm.
some check maybe to. So if this is the subarray sum till this point, and I do the entire subtraction of the left subarray. But what if it just had to be subtracted from here to here, right? So okay, okay. 8 minus 3 is 5. Okay, I think I got some. I think I have done something similar to this. So 8 minus 3 is 5, and which is like kind of like 5 plus 4 is 9, and 9 minus 5 is 4. So something like this. Like basically, I think there was something around this that if you get a similar value in the map or something again, then that kind of means you have visited that element, something like this.
Yeah, so I can
So
explain it to you, and we can probably stop here because I think we're like quite a bit over.
yeah, yeah,
So basically, what I was hinting at is like, so let's say you have a sum of 3 here, and I want a sum of 4, right? So
right,
basically, I know like if this whole thing sums up to 3, and I find something that sums up to 3 minus 4, which is over here, then I know that like this sums up to 3, the other thing summed up to -1, and then from -1 to 3 is 4. So it's kind of like a two sum where you get like the complement. So you basically look for like my current sum minus k, and then like the thing between those two is your like subarray. So it would basically be these two. Like if I'm at 3, um,
okay,
I need to look for 3 minus 4, which is -1, And so then the prefix sum is just everything after the first one up to the second one, which is these two numbers. And if you look here, then it's like this. So you can basically just store prefix sums and like the index where they occurred. And
Okay.
because you want the longest one, and if it occurs multiple times, you only store the first one. And it's basically like two sum where you just have a cache of like, these are my sums, this is the index, does the complement exist, and so on. Okay, so let me go through the feedback. I think, yeah,
Yeah.
I think that we did like 3 or 4 problems. So I think I kind of found the area you should focus on the most. So yeah, basically for the first problem, you clarified the problem in your own words, but you didn't figure out that like the root wasn't given. So I think a couple things, like read the problem carefully and ask if you're not sure. And that would have helped you because like you kind of had a solution and it was pretty valid if I gave you the root. But because I didn't, it
Yeah.
doesn't work, right? Because you don't know where to start.
Right.
So your main problem is you take too long. So like you asked like, how would you grade things? And I think there's like a couple sections that are important. The first is like problem solving. Like you get a problem and how fast can you like plan it and figure out what to do. Um, the second part is like coding, like what's your code quality? Like, do you know how to write stuff? And then the third one is like DSA, like are you familiar with like algorithms and data structures and all that stuff? And I'd say the fourth one is like communication, which I think you do pretty well in, but you get stuck a lot in terms of just like problem solving. So I think the biggest problem you need to focus on is just like problem solving. So going from like reading a problem to writing down in like pseudocode or something, like what's the algorithm I need? Like how would this work? Because it takes you a very long time to go from problem to like a working solution before the coding part, and you just like run out of time before you can code because uh yeah, because it just like takes you too long. So I don't know, did I ask you before how many leak codes you've done?
Yeah.
Okay.
Around 700 something.
Okay. So yeah, so it's surprising to me. Like maybe maybe you
Mm.
do ones that are like a little bit too easy. It's surprising to me that it's taking you like this long to figure out these solutions because these aren't like insanely hard problems for someone who's done 700. Um,
Right.
so definitely that's the biggest part I'd focus on is like maybe not like I don't know if you just like memorize solutions or something, but it definitely seems like it takes you a long time to go to like from the problem to like, okay, what's a valid algorithm, what's a pseudocode I can use, and so on. And so that was your biggest problem in the first one is like like I think it took you like 30 minutes to get something before we even coded. And so ideally
Right.
you want to have like the plan done in like 10 or 15. And if your plan is very clear, which to be fair, like the stuff you did come up with was pretty clear, then you can code like then that's like the next part to work on. But you should be able to go from like a plan that's like in pseudocode or whatever it is to a working solution in like 5 to 10 more minutes, right? Like the code is not that hard if you have a very clear like step by step of like what I need to do. If it is taking you a while to code, then I'd work on like the coding part. Like, okay, I'm getting the algorithm correctly. Now I need to work on the coding. But for you, you're like consistently getting stuck on the part before the coding, which is like coming up with the actual solution. And same thing for the second problem. Like you went for like the second problem was even more like I don't think it was like easy or anything, but it was even more cookie cutter, like very clear in terms of the requirements, right? Maybe the first one was a little bit
Right.
confusing. The second one was
Yeah.
like, I have a subarray, I need a sum equals k. Like there is no really there isn't a lot to explain, right? It's a very clear problem statement. And so like for me, like I instantly recognize that like because you went with the sliding window, that wasn't going to work because you have negative numbers. You can't have this shrinking constraint. And so you have to go towards prefix sum. So like you basically need to recognize that this is a prefix sum problem as quickly as you can and recognize like, okay, if it's a prefix sum problem, I need to look for like the complement sum, and then from there you can get a plan very quickly. But if you don't recognize that it's a prefix sum, then you're just kind of like you really can't do anything. So you want to
Right.
so that's the things you want to recognize, like a what bucket of problem is it, and b how do I quickly come up with a how do I quickly come up
Working.
with like a plan. So I can quickly show you what that would look like. So I would say like, okay, so this is a prefix sum problem, and basically I need like store index of every sum, leftmost indexed. So I would just have like a map, and then like for this example, I'd say like at index 0, or yeah, or some 0 occurs at like index -1 because it's like before. some 1 occurs at index 1, or not 1, it'd be some 1 occurs at index 0, some -1 occurs at index whatever, and so on and so on. And then if a number appears multiple times, if I run into -1 again, I want to store the leftmost one because I want the biggest subarray possible. And then basically for every number, for every index, do current total minus k, check in the map if it exists, and the length is whatever, like the current index minus like map index or something. And then you can just store the max there. Something like that. Like you want to be able to go from the problem to something like this very quickly, and then from there, like, you know, if I give you this, you could probably code this in like 5 minutes, right? It's like pretty simple.
Right.
So that's the main thing I would work on, is like maybe not even do the coding, just like do the problems and time yourself and make sure you can get a correct algorithm in 5 to 10 minutes. And something that actually worked for me is you can literally put this into like GPT or whatever, say like, I'm going to give you a problem, I'm going to give you a solution in just pseudocode and rate my solution, you know, in like 1 through 10, and like, and then time yourself and do that. And so you want to consistently get this plan like done in, for mediums, like 5 to 10 minutes, and you were taking like 30. So that's the biggest thing. Once you can get that, then go from the plan to the code in like another 5 to 10 minutes. And then once you get that consistently, then go for like a dry run. Make sure your dry runs are correct. So those are like the different steps I would do. But the very first thing, like if you take 30 minutes to come up with a solution and you have 20 for the problem, like I don't even get to see what your code is. You know, you might be the best coder in the world, but like you just run out of
Right.
time. So
Okay.
yeah, so that's the main things I would focus on, is just like speed, speed in coming up with a solution. So yeah.
Okay.
Let's see if I had anything else. Yeah, and the other thing is make sure you ask the important clarifying questions that actually matter for your problem.
Right.
Like in the second one, there wasn't really much, but in the first one, you didn't ask about this root thing, and then that kind of made your whole solution fall apart. Because you were like, all right, I'm ready to code, and then I was like, oh, by the way, I didn't give you a root. So, you know, you definitely don't want that to happen. So those are the things I'd focus on. It's like clarifying questions, and not even coding related, just like get an algorithm working in pseudocode or whatever, plain language. Yeah, and you can use GPT to just like practice that kind of thing and time yourself.
Okay.
Okay, cool. And yeah, if you want to do any more in the future, feel free to sign up. And then, but that's hopefully where I see like the biggest improvement from you. Is just this plan needs to be like done like 2 or 3 times faster.
Right. Okay. Thanks, Anthony, for the feedback. I think I'll try to work on the feedback that you have given. Yeah.
Okay.
Thank you so much.
Yep, no problem. And I'll upload this one as well, and I am going to upload the other ones I have with other people, so you can kind of see like the difference and stuff. Okay, cool.
Sure.
Catch you later.
Thank you.
Bye.
Good. Yeah.